Well, for your enjoyment, here's another example where we're going to find and evaluate the partial derivatives with respect to x and y at a particular point, the point x equals 2, y equals 1. And then I'll ask a question about not just finding the partial derivatives, but what do they actually mean. I expect you to think about that. We don't have to think too hard. So, here's our function of f of x and y. It's 4 minus x minus 2 squared minus y minus 1 squared. And if you think about it, it would be the same as 4 minus x squared minus y squared, except it's been moved over 2 units in the x direction and 1 unit in the y direction, moved to the right, or in the case of y, moved up 1 unit. And here's what it looks like. It's an inverted paraboloid, if you will. Here's from the side, and we're going to be looking at the partial derivatives with respect to x and y at the point where x is 2 and y is 1. And I don't know if you're aware, that means right up here on the tip top. So let's do that. The partial derivative of this thing with respect to x, well, if we treated y as a constant, then the derivative of 4, that's a constant, so that's 0. The derivative of this part, that's a constant, so that's 0. It's just going to be 2 times the quantity x minus 2 times the derivative of the inside function, which is just 1. So it's negative 2 times x minus 2. That is our derivative. And we want to evaluate that at the point where x is 2 and where y is 1. So if you put 2 in here for x, of course you get 0. Similarly, if we found the partial derivative of this function with respect to y, the derivative of 4 is 0, the derivative of the x part, that's a constant, so the derivative of that 0, it's just negative 2 times y minus 1 times the derivative of y, which is just 1, so it's just negative 2 times y minus 1. And if we evaluate that at the point x is 2, y equals 1, then we get 0 for that also. What would this tell you about a function in Calc 1? It would say, well, we have a critical point at the point x equals 2, y equals 1. Did it say the same thing here? Kind of. You could probably see, if you look at this graph, that there is a maximum point for this paraboloid up here at the point where x equals 2, see, and y equals 1. And so it does kind of tell us something very similar to what it would have done in Calculus 1, where the derivative is 0, and we could have a minimum or a maximum. Well, it's a little deeper than that, but for this example, it is almost the exact same thing as we would have done in Calculus 1.